let's have a look at what I've got to fit onto this Micra engine. So the Micra engine, just as a quick reminder, is a CGA13DE or something like that, which was the latest engines fitted to the Micra K11. So we're looking at around engines sort of between 2000, late 2002, 1340cc. I think they were known as 1.3s in Japan and 1.4s in this country. They're the coil pack engines, which means there isn't a individual coil boosting the power for 4 spark plugs. Each spark plug has got its own coil to ramp up the power. But this is what I've created. This is what you might have seen me painting and welding and putting together. So it's got all the bits and, well, not all the bits and bobs, but it's got a lot of the bits and bobs out on there now. Just again, a quick recap. The stock Micra inlet manifold fells the cross member, the bulkhead cross member. You know, the bit that your clutch and brake master cylinders are bolted to. It literally just tries to bury itself in there, so the standard Micra inlet manifold wouldn't have worked. So I've had to create something which comes away from that, still fits under the bonnet, and lets me fit the fuel rail and the injectors and some kind of air mixing box at the top to do its job. So what we've got here is, we've got what remains of the Micra standard inlet manifold, which I literally just sawed off, and then on the back, welded to what remained of this original inlet manifold, some aluminium 90-degree tubular bends, some tubular aluminium pipe, and the top of these pipes are connected together with an aluminium flange. There's a flange there and there's a flange there. So what I'm basically trying to do, I'm trying to create 4 tunnels for the air to go down into this original Micra inlet manifold. So 4 lots of air going down pipes towards the engine, towards the cylinder head. To get the air into these 4 pipes, I've got to basically try and connect what's called the throttle body, which will be on the end of this distribution box at the top here, this big aluminium lump. I've got to try and get that single throttle body inlet, which is just a gate letting air in, into these 4 tubes, or I don't know what they're called. Are they called headers, or I don't know, but just pipes going down and out into the cylinder head. So there's this distribution box up here, which has the controlled volume of air going in there and down the pipes, mixing with fuel via an injection system at the front and doing what it needs to do. Now this distribution box, I hunted around for, I mean, there's loads of companies that make proper professional versions of these distribution boxes. They literally make them from stainless steel or aluminium, but I couldn't afford one of them. So what I did, I searched around on eBay for, I think I must have put into the search engine on eBay something like inlet manifolds or plenums or air boxes. I looked all over and I found what looked usable, and it was off a, what was it off now? let me think, it was off a Toyota 2 litre 16 valve. That was the badge on it anyway. Unfortunately, the centres for the pipes never match up, so I had to cut them off, weld them shut, open up 4 new holes in the bottom for these pipes to attach, and just basically get the centres to work and get the air in there. So that's what it simply is. It's 4 pipes coming down into the cylinder head, 1 for each cylinder, and a distribution box on the top. There's a few outlets on the top which are useful. There's 3 on this one. There's this one, this pipe here, this little pipe coming onto there, which I think is the fuel pressure valve. It regulates the fuel pressure. That one I've capped off, and strangely enough, the heater tap, which gets fitted on the engine, a blanking plate on that one, finished that off quite nicely, but I could tap into that one again if I wanted to, if I ever needed vacuum for something else. And then I'll have this other one here, which I think I'm going to be feeding into off the camshaft cover on the top of the engine. There's a pipe sticking out there which went into the old air filter box arrangement. So that's that. If you look, if you look just up there, these blue things here are the injectors. They basically open and close and squirt fuel into the airstream, atomises and goes into the chamber within the engine's cylinder head. The fuel is shared out by this fuel rail across the top. The fuel is pressurised via a pump. I think it's about 3 bar pressure. It's not pressurised on a normal mini carburettor engine, A series engine, but there's about 3 bar of fuel pressure sitting in this common rail across here, and it's allowed to squirt out via a computer controlled ECU module, ECM module, whatever you want to call it, at intervals to regulate the fuel and get it ignited. So yeah, pressurised fuel coming in to this pipe. Ultimate pressure is controlled by this valve here, and this valve is fed off the vacuum within this airbox through this pipe. It's regulated by the control module, and any excess fuel is fed back into the fuel tank in a loop by this other pipe here. There are this is where the connection modules push on to receive the electronic pulse that tells it that it's got to open up and let the fuel out. So that's my layman's terms of it. Like I say, I've said before, I'm no expert on this, I'm learning as I go, but it all seems pretty much common sense when you think about it. There are different versions of this, obviously. There's some engines which fire this fuel directly into the chamber within the cylinder head. There's other systems that fire the fuel into the air distribution box, and there's other systems that fire the fuel into the throttle body. There's multi-point, which this is, I'm presuming, multi-point injection, because you've got more than one point. But there are, as there is the case in 90s minis, where you get SPI, single point injection, which probably just fires it into into the manifold as a single point, and then you get multi-point, which I think has got 2 injectors on them. Correct me if I'm wrong, but I don't know anything about them. But yeah, this is a multi-point injection fuel rail, sometimes called, I think, EFI, electronic fuel injection. Loads of different terminology. Bosch is the name behind this system. It's got Bosch written all over these bits and pieces on it. And I think fuel injection's been around on production cars since, early 90s. So it's been around a while and it's moved on. But I'm only just starting to get my head around it in the 2020s. So that's what it is. So what regulates the airflow going into this distribution box? Well, what it's called is let me show you, a throttle body. This is the standard one off the Micra 1.4 engine. So it looks a bit like a carb, really, when you look at it. It's got that same kind of feel to it. It's got something that lets the air in there. It's got a butterfly opening on it, which is controlled by the throttle cable. As you press your foot to the floor, that opens up. So yeah, air in, air out. It's as simple as that. There's no fuel in this thing here because that's done by the fuel injection. That's done by those little squirty things there, squirting the fuel in, just beyond the cylinder head. But yeah, this is all it is really. This is like a cat flap for air. It just lets air in, and by opening that, it lets air out. There are obviously, on any modern engine, there are devices, sensors on here, which take readings of what's going on to feed back to the ECU, or the electronic control module, to tell it how the engine is performing and how much fuel to let into this thing. Sorry, not fuel, air, how much air to let into this thing, which obviously influences how much fuel is injected in as well, how long to have those injectors open for, depending on the load of the engine. So you've got 3 plug-in things on this throttle body. You've got this one here, which looks like it's attached to the butterfly, and I believe that one is the throttle position sensor. So that senses how open and closed that is, feeds that information back to the ECU and lets it do its magic computer stuff. There's another one here, which is, I don't know whether you can see it, but this one here, which kind of crosses across the air intake here, and I think you might be able to see it if I open up the butterfly thing. Not sure, it crosses, it sticks out into the airflow, and that is what's called a MAF sensor, or a mass airflow sensor. It senses basically the volume of air which is whistling through this thing. It does it by interrupting the airstream. I think a MAF sensor is just a piece of heated wire which gets cooled by the air, and as the temperature changes, it sends a different signal back to the ECU and lets it know what's going on with how much air is going through it. So that's the second one. I think the third one up here is called an idle control valve, I think it's called. So it tries to determine what airflow is going through at idle. So the ECU can judge how to regulate the fuel and anything else which it needs to regulate. And what you've got basically is, I don't know if you can see it, but there is a bypass to this butterfly. Once that cat flap is closed, no air is going through this main circle. But there is the possibility for air to bypass it and go through that little chamber, which is controlled by this valve down here. So this big black lump on the bottom, this sensor, and the air going through this idle area where you haven't got your foot on the accelerator. You just need some air to go in through this to keep the engine ticking over at idle. And this piece of magic here, this sensor, gives the ECU data to tell you what's going through and how to best judge the amount of fuel to put into the engine at idle. Because I'm presuming there's different characteristics that an engine has at idle than it has trying to accelerate and cruise at a higher speed or decelerate. So yeah, all electronic gizmos on here, 3 of them, which helps the brain, the ECU brain, make sure that the engine is running efficiently, and allows this to do its job. And what happens there is that will just bolt on to this adaptation I've done at the end of that distribution box. That will, which way around does it go? And it goes on like that. That will just bolt on like that. There's a gasket on there, and then I've just got to plumb it in and wire it up. So plumbing the fuel in, plumbing a few vacuum lines in there, attaching the electronic parts to it, and seeing if it does its job. I think it's as simple as that. I don't think electronic fuel systems are really, after all my investigations, are that complex, really. I've got to be honest. Obviously they're more complex than an SU car, but yeah, it seems pretty simple. Cap flap lets the air in. It's controlled by a few electronic sensors. The air gets mixed with the injected fuel, and the brain knows what it's doing. The little computer program in there, set to the factory parameters, is doing what it needs to do. Simple as that. So we'll have to get all this mounted up on the engine. I've got this inlet pipe. I've got to feed onto this to try and get some coldish air in from the grill area, so that'll attach onto there. So there's a bit of plumbing to do. Let's see how we get on. Sorry about that. Let's crack on with it. Thanks for watching.